Hi, this is the presentation of the web application we built for the online pharmacy. This is designed by me, Jonathan Peng, Xiaomei Fan, Matthew Luca, Zihan Li. The defining of the problem, our current system of prescription order by in-person visit is inefficient. There are troubles such as long waiting lines, limited pharmacy hours and personnel, medicine availability, and so on, which deter patients from obtaining their prescription in a convenient way. We built the web application online pharmacy in order to provide an efficient solution for patients to access the availability of the prescription and make an order without physically being in the store and waiting in line, while allowing the pharmacies to manage prescription orders for better delivery in drugs. For any registered users, they are capable of walking through the prescription order procedure online and simply pick up the prescription at the store without wasting any time.
This is our use case diagram. We have users, pharmacy, system developers who can access our system. Users can register and log in their account, and our system will verify that user is registered. They can also view medication information and request prescription. When they request prescription, our system will verify that user is authenticated. We also have pharmacy and system developers who can create, update, view, and delete model information from our database.
This is our system architecture of our application. It is a client-server architecture. For each customer we have, it will interact with our front end, which is built in React. Our React front end will interact with our API, which is built with Java Spring Boot, which interacts with our pharmacy database. This is our state diagram. When a user opens our shop application, they will be sent to a verified account. However, if the user token is already expired, that verified account will become an unverified account. When they're unverified, they can either register or log in. If both registration and login fails, they will remain as an unverified account. However, if login succeeds, then they will change into a verified account. From here, they can either sign out to go back to an unverified account, or they would be in a state of either an empty cart or a cart with prescriptions. Assuming they're at a state of an empty cart, they can either request prescriptions to become in a state of cart with prescriptions, or they can just close up the application. Assuming that they are in a state of cart with prescriptions, they can check out and pay for these prescriptions, which will return them to an empty cart, or they can just close up the application entirely.
Right, so for our ER diagram or entity relationship diagram, we are displaying all the data models used in the backend and the SQL database. For this includes all the model names, how they relate to each other, whether that would be through a one-to-one relationship or a many-to-one relationship, as well as all the attributes of the fields. Within the attributes, the underlined attributes are the primary key of that data type. For every data type, the primary key is an ID field. All right, hello, welcome to our demo video for our pharmaceutical web app. So off camera, we already have created an account and we can use that to sign in. Right now the password is 123. However, if we were to make it 1234, which is the incorrect password, our sign in page throws an error. You can see now that we can now sign in with the correct password. We go to create an order. Here are the medications that we've already pre-populated the database with. So I'm going to go ahead, I'm going to select penicillin. The dosage and price are automatically filled in. We're going to request a quantity of 2 dosages. I'm going to press submit. We could then enter our card details, either credit or debit. I'm going to enter in some test ones here. so that we're not actually charged. My name here. And we'll do submit. So that is successful. We can now see the order history here, where you see the timestamp of when the order was actually made, the medication, the identification number, as well as more details about the order itself. We could view our profile information by pressing the profile button here. So this is our registered name, phone number, and email with our account. And then if you are a like a pharmacist, you can go to Swagger UI, which is a built-in function with the Spring Boot API. And here we have all the different endpoints for different models here. So for example, I'm going to show you what a request in this admin panel looks like. We're going to press add a new medication, try it out. And we'll put the dosage as 20 milligrams. The ID field is not needed as it's auto-generated by our backend information. We're going to say treats infections. We're going to call the name. We're going to say antibiotics. The price we'll set at 20.5. The price value in the medicine model is float. We'll put the section ID as 1, which we had already created before. We're going to press execute, and we can see now what it would look like in a curl command. What the actual URL that we're requesting to is the HTTP status code, which is 201, which means we've successfully created it. We have a message and a timestamp of when this was actually completed.
Some major takeouts from this project are learning how to visually represent our application with various diagrams such as the detailed class diagram, state machine diagram, and so on. How we manage our time as a team with our plan drive software development process, and how to clearly identify our stakeholder and requirements. We also learned quite a bit in regard to coding, as we have learned how to develop an authentication system, our front end in Reaction, and our back end in Java and MySQL.